Hello, this is Mrs. Boots. We're going to work the practice problems for quadratic inequalities. Number 1, I have the y in front, which means I'm going to draw a graph. From standard form, I know that my y-intercept is 3. Now let's find our roots. So we're going to factor. What multiplies to give me 3? Well, that's easy. It's just 3 and 1. We put in our minus signs so that they add to give us the 4. So when I set them equal to 0 and solve, I get x equals 1, x equals 3. So I have a root at 1 and a root at 3. Does this inequality symbol have a line underneath? No. So let's draw it dashed. Now we have to figure out where to shade. It's a less than symbol, right? So I'm going to shade where the y-axis is less. It's less at the bottom. So I shade at the bottom. That will be outside my quadratic. We should check that and make sure that we've got the right shading. So I'm going to pick a point to check. Try and pick something with small numbers. If at all possible, use 0, 0. So 0, 0 is right in the middle of my shading, which means when I plug it in, it should be true. So plug in a 0 for y, less than 0 minus 0 plus 3. Simplify. Is 0 less than 3? Yes, which means we shaded in the correct location. Number 2, I have a y, so I'm going to graph. I know that it's facing up because the number in front of x squared is positive. Let's factor. I can pull out a GCF of x, and I'm left with x minus 7. If I set each piece equal to 0, I get x equals 0 and x equals 7. Let's put those on the graph. Now what kind of line do I draw? Well, there's no line underneath in my inequality symbol, so I'm going to draw a dash. What's the inequality symbol? This inequality symbol is greater than. Greater than means shade at the top. The top of my y is on the inside of my quadratic, so the shading is inside the quadratic. Now let's check a point. Which point should we check? Well, 0, 0 is on the curve, so we don't want to pick that one. But let's pick one that's super easy. Let's try 1, 1, right there in the middle of the yellow. So plug in a 1 for y, greater than 1 squared minus 7 times 1. So is 1 greater than, that ends up being negative 6. Yes, that means I shaded in the correct spot because I picked a point in the shading and when I plugged it in it was true. We have to have the true condition when we pick a point in the shaded area. Number 3, what do we know about this one? Well, we have a negative in the front, so we know it's going to go down. It's going to face down. My y-intercept is the 8 at the end. Let's find the roots. So I need to factor. I'm going to pull a negative out just to make my x squared up front positive to make it easier to factor. Two numbers that multiply to give me 8 and subtract to give me 2 are 2 and 4. So I get my roots at positive 4 at negative 2. We know the parabola faces down. Now, was I supposed to draw it solid? Yes. We have an underline under the inequality symbol, so it is drawn solid. Now let's look at where we shade. What is the inequality symbol? Well, it's a less than. So that means I shade at the bottom. The bottom of the y-axis is inside my quadratic curve. Now I have to check a point. Which point should we pick? The easiest point there is. So 0, 0, plug it in. I have 0 less than equal to 0 plus 0 plus 8. Simplify. Is 0 less than or equal to 8? Yes. That means my shading is correct. Number 4. The negative out front tells us it's going to be facing down. The 4 tells us the y-intercept. Now let's look for the roots. Factor out the negative sign. X squared plus 3x minus 4. Now, what are two numbers that multiply to give me 4 and subtract to give me 3? Yep, it's just going to be 4 and 1. We would have the 4 with the plus, same sign as the middle, 1 gets the minus. So my roots, change the signs, are at x equals positive 1 and x equals negative 4. Let's put those on our graph. Positive 1 and negative 4. Now I have a quadratic. What kind of line am I going to draw? Well, it's going to be a solid line because I have the equal to mark. So I draw a solid parabola through my points. Notice I didn't worry about finding the vertex in this problem. That's okay. Now let's look. Inequality symbol. Where do we shade? The inequality symbol is a greater than. So I need the y-axis at the top. What's a good point to check? Well, 0, 0 would be inside. There's a good outside point. 2, 0. Let's plug it in. So, I have 0 greater than or equal to negative of 2 squared minus 3 times 2 plus 4. Let's simplify. Negative 2 squared, it's 2 squared and then negative, is negative 4. Negative 6 plus 4 ends up being negative 6. Is 0 greater than or equal to negative 6? Yes. That means we shaded in the correct area. Number 5. What do we know about this quadratic? Which way is it facing? Well, it's a positive x squared, so I know it's facing up. Let's factor and find our roots. I can pull a GCF of x out. I'm left with x minus 1. So my roots would be at x equals 0 and x equals positive 1. I'm going to space these really far apart just so I don't run into each other. So there's 0 and positive 1. Now let's look. What kind of line am I going to draw? My curve should be dashed because I don't have a symbol. I don't have that equal to. So I'm going to come in and draw a dashed parabola through my two roots facing up. Now let's figure out where we shade. Shading is greater than. Greater than means top of the y-axis. The top of the y-axis happens to be inside the parabola. So we're shading inside the parabola. Now let's check a point. What point should we check? Well, 0, 0 is on the curve, so that's not a good one. Let's pick 1, 1. That's usually the next best point to pick. So I'm going to plug that in. Is 1 greater than 1 squared minus 1? So is 1 greater than 0? Yes. That means we shaded in the correct location. Number 6. My quadratic has a y. That means I'm going to graph. So what can we graph? Well, I know it's facing up because up squared, x squared, is positive. What else do we know? We have a 6 at the end. That's the y-intercept. So we're going to put that on the y-axis. Now let's factor to find some roots. What two numbers multiply to give me 6 and add to give me 5? Well, that's 2 and 3. So I have x plus 2, x plus 3. Remember, they both have the same sign as the middle. Set them both equal to 0. So my roots would be at x equals negative 2 and x equals negative 3. So negative 2 and negative 3. This is going to be a skinny parabola. Now, let's determine what kind of line we draw. Is this a solid or a dash? This is a dash. How do we know it's a dashed? Because it doesn't have the equal to. So we come in and draw our curve, dashed, through our roots and our y-intercept. Now we have to shade. My inequality symbol is less than. Less than shades at the bottom of the y-axis. So find the bottom of the y-axis and shade. In this case, the bottom is outside of my parabola. Now let's check it. Check a point. You could check the point before you shade. That way you don't waste colored pencil. What's a good point? Well, 0, 0 is in my shaded area. So let's use that one. Plug it in. 0 less than 0 plus 0 plus 6. So 0 is less than 6. Is that true? Yes. That means my shading is correct. Number 7. Number 7 has a number in the inequality. It does not have a y. That means I have to look at a table in order to find my solution. I can use the calculator and do second graph to see the values of my table. If you do that, plug in your equation into y1. Let's write down the table. I'm just going to write some of the values. So at -2, it's 20. -1 is 0. Notice I'm looking for zeros here. 0 is -12. I'm going to skip down just to save some space. 3 is 0 and 4 is 20. So I want everywhere that y is less than 0. That's what we look for. Well, it's equal to 0 at -1 and equal to 0 at 3. And everywhere in between those two numbers, it goes down or negative. That means I can go from -1 to 3. But we don't use brackets, we use parentheses because it's not equal. So make sure you remember when to use your parentheses and when to use your brackets. Number 8. Number 8 also has a number instead of a y. So I'm going to look at the table and I'm looking for that number in my table. So I plug in x squared minus 10x plus 9 into y1. When I look at my table, I look for everywhere y is less than or equal to 0. I'm going to write down some of the values. At 0, it's 9. At 1, it's 0. 2 is -7. Okay, so I've gone negative. Let's skip down. ... At 8, it's -7. At 9, it's 0. And at 10, it's 9. So now it's going back up. So where does it equal 0? Well, that's at 1 and at 9. And everything in between those two numbers is less than 0. So I write my interval notation, 1, 9, and now I use brackets because we are equaling in my notation. The inequality wants them equal, and so we include the 1 and the 9 in our answer. Number 9. Again, I'm looking for 0. This time greater than 0. So I'm going to plug my equation into y1 and look at my y values greater than 0. So let's write down a few values. At -3, it's 5. That's greater than 0. -2, it's 0. Okay? At -1, it's -3. So now that I've dipped down, I'm going to scroll down. ... I see at +1, it's -3. At 2, it's 0. And at 3, it's 5. At 4, it keeps going up. So I know if I start from -2 and go more negative, it's going to be greater than 0. And +2 and go more positive, it's greater than 0. So if I keep going in the negative direction, that's negative infinity. And in the positive direction, that's positive infinity. So let's write that out in interval notation. We have negative infinity to negative 2. Do we include the 2? No, we don't have an equal to, so it gets a parenthesis. We do our U shape, positive 2 to positive infinity. This is the interval at which my function is greater than 0. If I looked at the graph, what I would see is in the curve, the x-axis would connect at negative 2 and at positive 2. And the parts of the parabola that are above the axis are going out to the infinities, negative infinity and positive infinity. Number 10. Again, I'm going to do my table. I'm going to plug the equation into y1. And I'm going to look for the number 600 in my y's, so I can see where it's greater and where it's less. As I scroll down, I see negative 6 is at 756. Negative 5 is at 600. So I go negative 4 is at 456. So let's scroll. Scroll. I go to 19. 19's at 456. Now it's going to start coming up. 20 is at my 600. And 21 is at 756. So my 600 is at negative 5 and positive 20. Everything that's less than 600 is between those two numbers. So I go from negative 5 to positive 20. Now, do I have brackets or parentheses? We have parentheses because the inequality symbol does not have an equal to. This is the interval at which my graph is underneath 600. So if you looked at a graph and you have your parabola, we would have a line for 600. That line would connect at negative 5 and at 20. And everything underneath the line is what we're looking at. Number 11. Once again, plug your equation into y1. So you have y greater than 6. Okay. So I look at negative 2 and I see it's at 18. Negative 1 is at negative 1. 0 is at 0. And 1 is at 21. In this case, I don't have a 6 in my table. But I do notice something. 2's at 18, so there's a break. Somewhere between negative 2 and negative 1 in my x values, my y's drop and the 6 happens. It also happens between the 0 and the 21. 6 would be in between these two numbers. So let's look at the x's. The x's are negative 2 and positive 1. So we would go with negative 2 and positive 1. If we wanted to, we could use the quadratic formula to find the exact roots and exact values so that we could have them. In this case, I'm not going to make you do that. So your answer is simply negative 2 to positive 1. Number 12, the last practice problem. Let's plug our equation into y1. So I'm looking for where y is greater than 0. Go to the table. Let's copy some of those down. I have negative 1, 65. 0 is 21. 1 is 1. 2 is 5. And 3 is 33. I scroll back and forth, but I don't see any number that's actually less than 0. So let's look at the graph. When you look at the graph, you'll notice it never actually touches the x-axis. That means it's always going to be greater than 0. So I can go from negative infinity all the way to positive infinity, and my graph is always going to be positive. It's never negative, which is good. If this were a business model, that means I'm always making money. It may not be a lot of money, but I'm always making money. Just not as much as I want, but I'm not losing money in any particular case. Let's do the 4 word problems. For the word problems, remember we have an equation that we used in the notes. The negative 16 is our gravity. That's 1/2 times 32. I know gravity is technically negative 32.2, and we rounded, but it's 1/2 of that. Our v is our velocity. So whatever they give us in the problem, we're going to plug it in for v. And h is our initial height. So if it says it's on the ground, that is a height of 0. Number 1, we have a toy rocket that's fired straight up from the ground level with an initial velocity of 80 feet. So my velocity is 80 and ground level is 0. So we want to know during which time interval it will be at least 64 feet above the ground. First, write the equation. Negative 16 x squared plus velocity, which is 80, x, you could put plus 0. At least. What does at least mean? That means it has to be greater than or equal to 64 feet. Now I'm going to look in my table. In my table, remember I'm plugging in the left side of my equation for y, and I want to find out where it is greater than or equal to 64. Let's write down some of the values. Well, 0, it's on the ground at 0. 1, oh, there's my 64. 2 is at 96. 3 is at 96. And 4 is at 64. 5 is back at 0. So, from 64 feet, starts at 1 second and ends at 4 seconds. Do I include the 1 and the 4? Do I use square brackets? Yes, we have an equal to, so we use square brackets. So the interval is from 1 second to 4 seconds. Number 2, a ball is dropped from the roof height of 120 feet. So my height is 120, during which period it will strictly be above 56 feet. So I want to know, where is it greater than 56 feet? Okay, well, we got to write the equation, right? Well, what's the velocity? There isn't one. So my v is equal to 0. So I have negative 16 x squared plus the 120. I don't write the v because it's not there. I want to know where it's greater than 56, not just equal to 56. Let's look at the table. Remember, you put the equation into y1, and we're looking for the value of 56 in the y column. So my x's are 0, y is 120. At 1 second, it's 104. Wow, 2 seconds is 56. That dropped a long way. In 3 seconds, it plowed through the ground because Superman threw the ball. No, not really. Okay, so obviously it hits the ground somewhere between 2 and 3 seconds. That's where the ground happens. But what do we want? We want to know where it's above 56. Well, at 0, it's above 56. But at 2 seconds, it's no longer above 56 because that's where it hits it. So I go from 0 to 2. Notice I used a bracket for 0 because 0 is included. But for the 2, it's not equal to. It's just the greater than. And 2, it's equal to. All right? Number 3. Company is conducting a missile test. On Earth, the missile is launched 50 feet off the ground. So my H value is 50. Okay? It travels at a velocity of 220. So we now know our velocity. Since it's on Earth, we know what gravity is. If the enemy can detect anything below 500 feet, so below 500 is less than 500 feet. When can the enemy detect the missile? So we have to look at this. It's going to go up on our side, come down on their side. We want it on their side, okay? We want it on the way down, okay? So let's look at the equation. Negative 16 x squared plus my 220 x plus 50. We want that to be less than 500. Okay, less than 500. So I'm plugging in my equation into into y1, and I want to look at y1 and see where is it less than 500. Let's write down some numbers from our table. Well, 0 is 50 because that's where it started to launch. At 1 on my side, it's at 254. But I don't care about my side. So I'm going to follow it all the way up. Dot, dot, dot. I'm going to start coming down. At 11 seconds, it starts coming down and is at 534. At 12 seconds, it's at 386. So it happens somewhere between 11 and 12 seconds. After that, they can detect it. So my answer would be after 11 seconds, the enemy can detect the missile that just got fired at them. So you have 11 seconds before they know you're coming. Number 4. Joe throws a football across the field at a velocity of 72. Awesome. 72 feet per second. The ball was thrown at approximately 5 feet off the ground. So my height is 5 feet. Okay. The receiver cannot see the ball when it's above 62 feet because of the stadium lighting. So I need to know where my height is greater than 62 feet. Let's look at the equation. I have negative 16 x squared plus 72x plus 5. I want to know where it's greater than 62 feet because I want to know how long it's going to be lost in the lights. It is also equal to 62 feet. Okay? So, let's look at our table. Well, at 0, it's at 5 because he's still holding the ball. At 1 second, it's at 61 feet. Ooh, we're close. At 2 seconds, it's at 85 feet. That means my receiver can't see it. At 3 seconds, it's at 77 feet. 4 seconds, 37. And at 5 seconds, it's gone through the ground. Realistically, it stopped somewhere between 4 and 5 seconds, right? So, where am I above 62 feet? Well, somewhere past 1 second and before I get to 4 seconds. So how long is it lost? Well, it's from, we can even say that that's 3.5, right? Somewhere between 4 and 5, so we'll estimate that it's 3.5. It may be a little less. So it's from 1 to 3.5 seconds. How long is that? So I take 3.5 minus 1, and that gives me 2.5 seconds. So the ball is lost in the lights for approximately, and we'll do a little tilde in there, approximately 2.5 seconds. That's a long time for that poor receiver to stand out there and not be able to see the ball.